Okay, in algebra, we can put points on a graph and we can look to see if there's a positive relationship, a negative relationship, or no relationship at all based on where the points are plotted. If I look at these three graphs here, on the first graph, we put a bunch of points on here. And if I look at the trend of these dots, it looks like they're all going in an upward direction as I move from left to right. If I was to draw a line through here, we would see that this has a positive relationship here, and it has a positive slope. Okay. In the second line, the dots all seem to be going down as I move from left to right, so I would say that this has a negative correlation, or there's a negative relationship between the x and the y. And in the third graph, these points are just kind of spread out all over the place. So there's neither a positive correlation nor a negative correlation. So we would say there's no correlation at all. So in the first one, I'm going to put positive correlation, or positive. Abbreviate correlation CORR. And for the second one, we see that there's a negative correlation. And in the last one, there's no correlation. Okay. If I was to draw a line of best fit, I would be drawing a line that goes somewhere through the middle of them that best represents that information. And for the last one, the reason there's no correlation is because I can't really tell where I would need to draw my line. Right? The points are just all over the place. Okay, so when a positive or a negative correlation exists in a scatter plot, a line can be sketched to represent the data. So that's just what I did above. Okay, so if we have here, we have a bunch of points all over the place, and then we have a line that goes through those points, and it kind of represents the data. And on this one, we have points here, and then we have a line that goes through those points that we think best represents that data. Now, all of our lines may not be in the exact same spot, but we get a general idea of the slope of the line and the direction it's going. Okay. They want us to write an equation for the lines graphed above in slope-intercept form. So first thing we did was we drew our line, and then from that line, we're going to need to find 2 points on that line that we can use to find slope and the y-intercept. Okay, so I'm going to use the y-intercept of 2, so my b is 2, so we need m and b to write our equation. Okay, so the m is going to be 2, or the b is going to be 2, and the m, so we're going to take 2 points on the line. I see that we're going to use that point. That was a good point. And then if I trace my line, I need to look for another point that's on a good intersection that about represents the slope there. Let's see. I think we'll use this point back here. So I'll put a dot here, and then we're going to calculate the slope. So slope is, remember, it's the change in y over the change in x. So we're going to look at the y-axis movement first, and that means we need to go up. So we went up 1, 2, 3, 4 units, so it's positive 4, and then over. Okay, then we went over 1, 2, 3, 4, 5. So about 4/5. So when I write my equation now, it's y equals 4/5 x plus 2. So this is the equation of the line that we found for the line of best fit. Now, just depends on where this line goes. You know, we could have shifted it up a little or shifted it down or changed the slope of it a little bit to make it less steep or more steep. But no matter what we did to it, it's going to be somewhere around this. So the fraction may have been just a tiny bit different, and The y-intercept could have been just a tiny bit different, but it's going to be really close. Okay, we're going to go to the graph next to it. We're going to do the same thing. We would see the points. We would then draw a line of best fit through it. And then now we need to write an equation for the line that we drew through those points. So in order to write an equation, we need to find the slope and the y-intercept. So I'm going to start with the y-intercept. That's the point where it crosses the y-axis, and that's at 1. So I'm going to put a 1 for the y-intercept, for the b. And for the slope, we need 2 points. So we're going to use the point we found already. And then it looks like this is another good point on the line, so we would use that one too. We see that we have a negative sloped line. So that means my slope, my m, is going to be negative. So we went down 1 over 2. So it's down 1 for negative 1 over 2. Now that I have my slope and my intercept, we write the equation y equals negative 1/2 x plus 1. And that's the equation that represents this line. And this is the line that best represents these points. Okay. Now it says write an equation for the lines graphed above. Oh, we did that. So given the scatter plots below, identify the type of correlation, draw a line of best fit, and write an equation for the line and slope-intercept form. Okay, so we have to identify the correlation, positive or negative, draw a line through the points, and then write an equation using slope-intercept form, which is y equals mx plus b. Okay, so let's look at the first graph. And it asks us to identify the type of slope. As I look at these points, it looks like it has a downward trend to me. Overall, it's going down. So I would say that it has a negative slope or a negative correlation. So negative correlation. Okay. Then I want to draw a line of best fit. So the best thing to do would be to take a straight edge and set it down through the middle and just kind of move it back and forth and see, does it go this way, does it go this way? So is it more steep, less steep? How's it going? So you kind of want to put your line where it goes through the middle of the points. It kind of has an even amount on both sides, and it's kind of in the general direction of the points. So I think this is actually a pretty good line right here. So I'm going to take my pen and I'm just going to draw a line through there. So I have some points above, I have some points below, some are on the line, but we get the general idea of how the line is going to go. Okay, so it's a negative correlation. We have our line of best fit. Now we need to write an equation that represents this line. Of course, when we do our own, when we're practicing these on our own, our equations might vary just a little bit. So the slope will be close, but it may not exactly be the same because it's our line of best fit, how we're judging how these points, what line best represents the points. Okay, so I'm going to pick 2 points, and it just happens to be 2 of them are right here. So we need to identify m and b to write our equation. So b is the intercept, and it looks like it crosses the x-axis at about, the y-axis at about -2. So we're going to write -2 for the b, and the slope, we see that it's negative, it has a negative correlation, and if we use these 2 points, it's going down 1 over 1. And if I simplified that, it would be just -1. Now we'll write an equation using the slope and the intercept that we have. So y equals -1x, or just -x, minus 2. Okay, we're going to go look at the graph next to it and do the same thing. So first thing that they asked us to do was to identify the type of correlation. I can see that these points are moving in an upward direction, or it's trending up. So I would say that this has a positive correlation. Okay. Now I need to draw a line of best fit, so a line that goes through the points and best represents the general direction of those points. And it looks like it's going to go through here somewhere. Okay, so I'm going to try to draw a line that goes about like that. Okay, and my line's not perfect, and that's okay. Alright, so we need to identify the M and B, so the slope and the y-intercept. The y-intercept looks like it goes through the y-axis at about a half. So here's 0, here's 1, and that looks like it's about halfway. So I'm going to put, for the B, for the y-intercept, I'm going to put 1/2. Okay. Then I need to find 2 points on the graph, and I'm going to use this point here. And let's use this point here. It's close enough. Okay, so if it's positive slope, I'm going to have a positive fraction. And I'm going to go, if it's positive, I'm going to go up first. So I'm going up 2 units. And then I'm going to go over 3 units. So I'll write an equation with those pieces. Y equals 2/3 x plus 1/2. Alright, so it says make a scatter plot of the data, draw a line of fit, and write an equation for the line. Alright, so first thing I need to do is I need to plot these points on the graph. So we're going to take the xy values and plot them. So my first one I have -2 and 2. So for the x we go back 2 and then up 2. So I'm going to put a point here. And then we have -1 x and then 1 for the y, so -1, 1 is right here. -1, 0, it's right here. 0, -1, it's there. 1, -2, here. And 2, -3 is there. Okay, there's the data on the graph. Now it looks like we have a negative correlation here. The points seem to be going in a downward motion. If I drew the line of best fit, I would say it's somewhere around here. So let's go ahead and draw a line in, and I think I'm gonna go about maybe like this. And that's kind of close. So we will take the M and B, we have to find the slope and the intercept and write an equation. The intercept looks like it's about 0. And then we can look at some points. And it looks like those are some good points we could use. So we see that it's a negative sloped line. So that means my slope, my m, is going to be negative. It's going down 1 over 1. And when I write that equation, y equals, so -1x, -x, plus nothing. Okay, for the graph below it and the table below it, we're going to do the same thing. We're going to put the points on the graph. So -5, 1 is here, -4, 0, -3, 1, -2, 3, negative 1, 2, and 0, 4. Okay, as we plotted those points, we started moving in an upward direction overall, and this looks like this might be my line of best fit somewhere between here. So I'm going to draw the line in. Okay. And it's actually pretty good. I have 3 dots right above it, 3 below it. Looks like it goes right down the center of it. And we will get our M and B from this, so our slope and our y-intercept. The y-intercept looks like it crosses somewhere between 3 and 4. Looks like it's about halfway. So we're going to say the B is 3.5, so 3.5. Okay. I could also write that as a fraction as 7/2. So either way would work. And the slope, it's a positive slope. We see that it's moving upwards. And we need to pick 2 points. I think I'm going to take this point here. And let's change that to black. So that point there. And another point, that looks like a good one here. Okay, so the slope is positive, so that means I go up first. We're going up 2 units and over 3. So we'll write that as 2 over 3. And substitute those into y equals mx plus b. So y equals 2/3 x plus 3.5 or plus 7/2. I'm going to go ahead and use the fraction, 7/2. Okay, below, profit. The table shows the monthly profit of a small company. So I look at the table, it's month for X, profit for Y. I see the months increasing. January starts, they're saying that's like 0. And February is going to be the first month, March 2nd, April 3rd, May 4th. And then here's the amount of profit for each of those months. Okay, so make a scatter plot of the data. So we're going to take the month and the profit, and we're going to put it on the graph. It's telling me January is 0, so the X is 0, the Y is 1200. So at 0, my profit was 1200. I'm going to put a point here. That is our Y-intercept, because it's on the Y-axis. Then for February, they're saying that's going to be month 1. So this, if we look down at the label of X, it says months since January. So that's why January was 0. If it's months since January and it is January currently, then it's 0 months past January. That's why we had the 0 there. All right, so February is the first month past January. And the profit there is 1,250. So that's going to be about halfway between 1,200 and 1,300. For the second month past January, we have a profit of 1,400. So that's about here. And we are now on April, so the third month since January. The profit is 1,380, which is just a little bit below the line here. And for the fourth month past January is 1,450. So that's halfway between 1,400 and 1,500. Okay, so we've made a scatter plot of the data. The second thing says find an equation that models the profit in dollars as a function of the number of months since January. Okay, so we need to write, before we do that, we need to find a line of best fit. And they actually gave us a starting point in this one. They told us the y-intercept was 1,200, right? Because we had 0, 1,200 for our first point. So my line of best fit actually needs to be here and then extend from that somehow, right? So the line of best fit looks like it's going to go right about through here. starting at 1200 because that is our y-intercept. So I'm going to draw a line through there, starting at 1200 and going up at about that rate. It's pretty close. So we're going to find an equation that models that in dollars as a function of the number of months since January. So so we still need to find the m and the b. So the m and the b is 1200, and now we need to find the 2 points. So 1200 is a good one, and this looks pretty close right here, right there. So that's going to be so to go from 1200 to 1500, right, we're looking at the movement up. That's 300. So it went up 300. And then from here to this point, went from 0 to 4. So 300 divided by 4. And when I put that into my calculator, I get 75 over 1. So the slope is, it goes up $75 every 1 month. That's just the average is what they're saying. Okay. So the equation, and if we're going to write it as a function, we're going to say f of x equals, we're going to take our slope, 75x, and then we're starting at $1,200. So this is the same thing as y equals. So it could be y equals 75x plus 1200, or if we wrote it in function notation, it would be f of x equals. Okay. What does the slope represent in this scenario? Well, I just said that. The y is profit, and we found that the change in y was 75. So it's going up $75 every 1 month. It says approximate the profit in June. Use the scatter plot. Okay, so May was the 4th month past since January. So June will be the 5th month. So if we went over 5 months, what about would the profit be right here at 5 when x was 5? And that's going to be between 1500 and 1600. And it looks like it's about halfway, so I would approximate the profit in June to be $1,550. Okay, approximate the profit in September. So I could continue the pattern on the table, or I could substitute the number that would represent September. So if June was the 5th month since January, July would be the 6th, August would be the 7th, September would be the 8th. So our x value for September would be 8. Okay. So if I substitute that 8 into my equation that I found, so it's going to be y equals 75 times 8 plus 1200. So 75 times 8 is 600 plus the 1200 gives me y equals 1,800. So the approximate profit in September, which is 8 months since January, would be $1,800 approximately.